one last thing I want to mention before we move on, and sort of as we move on into thinking about chemical equations, is that the idea of a mole is very useful in thinking about chemical equations. So chemical equations look something like this. This is an example from your textbook. Sulfur trioxide, practice our naming here. We're going to have sulfur trioxide here plus water, and we're specifying the phases here. These two are in the gas phase. React to form sulfuric acid. Right. This one's an acid, we know, because it has hydrogen at the beginning of it. H2O is, of course, a special case here. And this forms a liquid. Now, we can think about this a few different ways. First, and probably the most obvious way, is we can think of one molecule of SO3, of sulfur trioxide, will react with one molecule of water to form one molecule of H2SO4. We can sort of imagine that there are invisible ones in front of all of these, because we will, in the near future, encounter equations where these are not all equal to 1. And so we can say one molecule reacts with one molecule to form one molecule. These are what we call reactants on this side of the chemical equation, and this is our product on this side. If we've already discussed that, this is just reinforcing that. Another way we can think about this is, well, if we had, say, a whole mole of SO3, we could say that one mole of SO3, rather than one molecule, will react with a whole mole of water to form one mole of sulfuric acid, right? And we could even, and really what this is telling us is how many particles, right? What numbers of particles, what ratio do they react in? And this is what stoichiometry is all about. We could scale this however we want. There's nothing that says we have to limit ourselves to 1 mole. So we could say it's equal. We could say if we had 3 moles of SO3, that would react with 3 moles of water to form 3 moles of H2SO4, of sulfuric acid, right? Or half a mole reacts with half a mole to form half a mole. All right, and so chemical equations tell us the ratios, which is a really important concept. And what really helps is, thinking about this in terms of one molecule reacting with one molecule to form one molecule is what actually happens on the, little tiny scale. But, we can't look at that. We can't measure one molecule at a time, except under very, specific circumstances with really powerful equipment. But it is very easy to measure out a whole mole of SO3, right? We can weigh out the mass. Well, it's a gas, so we'd probably do it a little bit different. But we can measure that out, 1 mole and 1 mole, and know that they should react to form a mole of H2SO4, of sulfuric acid, and how much that would weigh. And so this is how we link this idea of moles with chemical equations. And in the next part of the class, we're going to be looking at chemical equations and how do we balance them so that we know this correct ratio between our reactants and our products.